Hello LM. So today we're going to talk a little bit about designing systems for every user, including people and LLMs. My name is Guust Ysebie and I'm currently working as a software engineer at the Price, where I mostly work on our PDF SDK. So I also work a lot on accessibility within PDFs, and that's the knowledge I want to share with you today. PDF documents today are not only consumed by people, they are also being consumed by LLMs. So they should be as accessible as possible for both these consumers. Which principles are useful for everyone? The first one is perceivable. It needs to be operable. It needs to be understandable, and it needs to be robust. Why am I telling you all of this? It's because it's all of those kind of issues that both humans and LLMs encounter when working with PDF documents. Let's have a quick look at the PDF. PDF is a container format. It means that you can use different kind of formats like fonts, like images, videos, put them together into one. The most important parts you have to understand is the drawing language. And the drawing language is just drawing instructions, which you can see displayed. What this does is when you have a canvas, like a PDF page, it just simply says like, move to this certain location, and then we need to draw these characters on this exact location. This ensures that when you open the PDF I created, that your PDF processor knows exactly on which pixel to render which content. But pixels and characters are like very different from what we actually do when we look at the PDF. Those pixels, we can actually assign reading order to it. We understand its semantics intent, and based on drawing artifacts like lines, like list symbols, we can determine what the author meant the data to be in. Of course, if you're an LLM, you don't have all that kind of meta information out of the box. The LLM just looks at the page and sees pixels. So it's very hard for LLMs then to extract the data from it. You would lose either a lot of tokens where you need heavy training, or you would need those text extraction so you can actually first extract the data from it and then train your LLM on the data. So what you have to remember here is what we see is very easy for us because we are trained up on it, but LLMs don't have this, and so it's very hard for them to interpret the actual meaning behind those pixels. If you, for example, would have a PDF, LLMs actually are quite good in extracting this kind of data. But as you can see on the left side, it doesn't have any structure. It doesn't really know what means what. Yeah, we can make a guess. Annual report probably as a title, but it's very hard and very inefficient to train your LLMs on because it can't apply semantic reasoning onto the context. On the right side, on the other hand, exactly the same context, but now we added semantic meaning. We added which part of the document is actually a header, which one is a table, and as you can see, it will be far more easier for the LLM and for your normal users to actually extract the semantic meaning. So in PDFs, normal PDFs didn't really have like this kind of system where you can tag content with semantic meaning. But of course, PDF evolved and now it includes a mechanism for this. This mechanism is tagged PDFs. You, as a developer, have the advantages because low-level tools do it for you. Because if we open a PDF now, for example, here, we can quickly see that now on the right, we have our text structure. So it means we actually have kind of the same structure you would know from HTML, while still having pixel perfect rendering on the left. So now we for sure know that, for example, the text in blue is an H1, below it is a paragraph, and then we have a table. So now we have pixel perfect rendering, and we have complete semantic information and metadata about our documents. So because we now have like this bunch of semantic information, bunch of metadata, and creating tools on top of PDFs are far more easy. Now we can just look into our text structure and see which text is there. This means assistive technology, search, extraction, and all the other things are far more easier to implement, because now we have a structured model of the data that we display within our PDF document. Text extraction is probably one of the most interesting things, because lots of developers need to process a bunch of PDF documents. So for our demo today, I did a quick demo where I built an LLM data pipeline. And on the first hand, we're gonna use OCR-based solution. We are going to use Docling in our circumstance. Why? Because it's the most well-used and one of the best tools out there. It's open source as well. And on the other hand, we are going to use iText SDK to leverage the embedded text system within the PDF, which contains all the metadata, instead of trying to analyze pictures, to actually extract the content we really want to. So let's get started. So we have this PDF document. This is just a normal summary with some tables, some lists, and some stress tests where we have, for example, a watermark into it and some very tiny little text. So the first thing we're gonna do is we're gonna run Docling on it, and we're gonna convert it to a markdown file. Why a markdown file? Markdown files are very information dense, so it means you have semantic information. So let's run Docling first. This script is quite easy and can just be executed with Python. This just reads the PDF document and calls the correct library functions to convert it to a markdown. While this is running and trying to extract the data, if we have a look at this, this is still warming up. It's loading a bunch of its models. This only has to be done once, of course, for Docling. So now it will start running the actual conversion. As you see, it takes a bit of time. So now you can see it's finally done. So to convert those 4 pages of information based on processing the OCR, so processing the pixels, it takes about 18 seconds. So if we look at the output we get generated from this, we see it's actually quite good. We have all the tables, we have the lists, we have even the difficult languages, but we also have the watermark, for example, which is not something we really want. So it's not the author intent to be actually extracted. And this might be used if you are using OCR tools to spoil your training data, because then the data will also be into your markdown file, and it might be used or abused to jailbreak your LLM. So how does it compare to the basic Java implementation where we use iText to actually extract the data and the meta information from it? Then it's a far different story. So now you see it's only 0.75 seconds. 0.075 seconds. So it's 200 times faster than the OCR implementation. And not only that, if we look at the output, you see the tables look exactly the same, the content looks exactly the same. But for example, the watermark, which the author didn't intend to be actually displayed or to be used or to be actual important data, is not there as we expected. And it's, of course, a lot better for security reasons and all those things. But what you also have to take into account, if we compare the list of widget nodes, we see here PDF OCR didn't manage to actually extract that those were sublists. Why? Again, because the semantic meaning was lost from the document. While if you are using the metadata which was embedded into the document, you see the sublist is correctly constructed. This means that the Docling OCR actually generates like some kind of mistakes which are very hard to trace, and those mistakes can compound over time, which in the end produce very wrong output formats. So that was the demo. As you can see, we generated the same markdown documents to then train our LLMs models on to extract the business data that we require. So what do we have to remember here? We need to design for understanding, not just rendering. And that's especially the case in PDF documents. So when you are producing a PDF, you should enable that the metadata is being embedded. This can be done in most PDF libraries by enabling a flag. Then you have to make sure that those tags are correct and convey the author's intent of the PDF document. And if you do those two steps, you have a bunch of advantages you get for free. You get smart data extraction, you get easy search, and your PDF documents are accessible. So you have to remember, accessibility isn't extra work. What you do now is only a few more minutes of work. And that means that your AI infrastructure, which you will build in the next following years, will be so much better at processing all your documents, which means you will have and gain a competitive edge just because you made your data accessible to both users and LLMs. All right. Thank you very much. If there are any questions, please don't hesitate to contact me or a price, and we will gladly help you out.